Wasabi, you guys. Welcome to Integration B Training for Advanced. In this section, we're going to be learning how to do forcing a Frullani integral. And it's probably going to be maybe the shortest section for this whole Frullani integral training. And forcing a Frullani, it could be any function, but for now, we're going to focus on arctangent because I can't find any other functions with certain identities like this. Okay, so let me show you what I'm talking about. So this is an amazing integral. A lot of people would use like residue theorem or something like complicated, like converting it into like some double integral or something. But obviously, we're going to do something much elementary. Maybe not elementary, but we're going to do something a lot easier and maybe faster. Okay? So, what we're going to do is we're going to force a Frullani integral. So how are we doing that? So the reason why we're able to do it with this function is because inverse tangent has a property that we all know. Inverse tangent of x minus inverse tangent of y. This is equal to the inverse tangent of x minus y all over 1 plus xy. Okay? So, why am I using this? Because, our whole goal is to convert this into this. Right? Just by using this is my goal here. Okay? But how? How am I going to do that? Well, so here, so how am I going to do that? So what we have is we want inverse tangent a of x. I'm sorry, not plus. We want minus, because Frullani requires a subtraction. Okay? We want this, and we want this integral. Let's see, if we have a minus b x 1 plus abx squared. Aha. So we want this to turn into this. Pretty much we're solving for a and b where this is equal to this. So here we see that we have a minus b equal to 1. And here I see that our coefficient here is 1 for x squared. So ab is equal to 1 here. Okay. So now we just have to solve for a and b. And in this case, of course, b is equal to 1 over a. Then we get a minus 1 over a equal to 1. And then this is a squared minus, I'll take that in. And when we solve for a, I'm just going to run quickly. When we solve for a, we get the golden ratio. Yes, this is the golden ratio. So, now that we know this, let's see, if a is equal to the golden ratio, then the b is equal to 1 over the golden ratio. So what we have here is that this, shockingly, yes, this is equal to 1 over x inverse tangent. I'm sorry, let me rewrite this. This integral is equal to inverse tangent of phi of x minus inverse tangent of x over phi dx. We already know infinity, inverse tangent infinity is pi over 2. ln of phi divided by 1 over phi which is phi square. So our answer is pi times the ln of phi, the golden ratio. Okay, so this is our answer. Shocking, right? You see how quick that was? You know, just use some quadratic formula, whatever, and then you just plug it in here, and then you just get to your answer, right? So forcing a Frullani integral is very helpful, very fast, while your other opponent can be doing something complicated. Okay, so let's do one more example, because unfortunately I can't find any other functions that have similar properties like this, where they have it's like some function minus some other function, and then a function inside. I'm sorry, a function of some whatever. Okay, but for now, let's go ahead and just practice one more time, getting comfortable with this identity. So now that I showed you how to force a Frullani onto arctangents, go ahead and try doing that with this integral. You know, so it's honestly the same. It's the same process, right? So here we want to find inverse tangent of, well, in this case we have square root of x minus inverse tangent b square root of x. This gives us inverse tangent of a minus b square root of x 1 plus ab x. Okay, so we're going to go ahead and we see that we have, oops, let me go back to orange. So we see that we need a minus b needs to equal to 1, right? And ab needs to equal to 1 as well. We already solved for this, right? A is equal to phi, b is equal to 1 over phi. And so here, what we end up getting is this is equal to pi over 2, and then ln of, well, be very careful. Be very careful. This is actually, we would actually end up getting inverse tangent. Because of the square root of x, phi needs to be inside. So we actually have phi square x minus inverse tangent of x over phi square. Okay, it's not the square root of x, it's the x that we need the coefficient. So what we really have is phi square over 1 over phi square. And this gives us 2 pi ln of the golden ratio. Okay? Alright. So that's pretty much it. You can you can go ahead and try it with I think this is from University of Florida integration bee. They did this. So you can go ahead and try solving this integral, applying the same technique. Okay? So yeah, this is your practice. Okay. And then I think University of Florida also has their solutions as well. They didn't show the process of it. I think they did something different. But forcing a Frullani is a lot easier to deal with. Okay? Alright. Thank you guys so much for watching. I hope this is helpful. And I'll definitely see you guys in the next video. See ya.